The uniform distribution is an example of continuous probability functions. Very similar to when we looked at probability of rolling a die. There's 6 sides and each side has an equal chance of showing its face. However, that's an example of a discrete probability rather than a continuous probability function. The uniform distribution is similar in the sense that any one of the variable values has an equally likely chance of being selected, but you can pick any number you want within the interval. So for example, we're looking at the function 1 over 20 for the variable values ranging from 0 all the way up to and including 20. Now if we wanted to calculate the total area under this curve, we would just need to remember that area is calculated using the formula base times height. So for this rectangle, we would calculate the base from 0 to 20, that's 20 units long, times the height. This function goes up on the y-axis, 1 over 20. And if we multiply the base, 20, times the height, 1 over 20, we get 1. Total area under the curve is 1, just like it should be. What if we wanted to calculate the area between 0 and 2? Well, that would be the probability that our variable value takes on a number between 0 and 2. That's the area of the blue rectangle we see on the screen. We'll need to determine the base of the rectangle and the height of the blue rectangle so that we could calculate the area. The base has a width of 2, the height is 1 over 20. Multiplying 2 times 1 over 20, we get 0.1. There's a 10% chance that our variable value takes on a number between 0 and 2. What if we wanted to calculate the probability that our variable is exactly equal to 2? Not 2.1, not 2.00001, 2 exactly. That would look like finding the width and height, the area of a line. But we know that lines don't actually have area, so this probability is equal to 0. In fact, for any continuous probability, the probability that our variable is exactly equal to a single value, always equal to 0. What about the probability that our variable is between 4 and 15? Well, that would be the bigger blue rectangle that spans from variable value 4 all the way up to 15, from the x-axis all the way up to our PDF curve. We can calculate the height, it's just the value of the function, times the base. And in this case, the base is 15 minus 4. How wide is our rectangle? It's 11 units wide. Multiply our base times height, we find that the probability that our variable value is between 4 and 15 is about 55%. What about calculating the probability that our variable is greater than 11? Well, that would be the right half of this rectangle, well, a little less than half. To calculate this, again, calculate the base times the height, multiply the two together to find the area. Area is our probability for continuous probability functions. Now the last few examples we did, we used nice, neat, discrete numbers, but because we're dealing with a continuous probability function, we could look at decimal numbers, fraction numbers, irrational numbers. Any real number could be our variable value. So let's do one with some decimals. Let's look at the probability that our variable lives between 2.3 and 12.7. Well, to find the base, I will do the 12.7 minus 2.3, and of course the height of the function is representative of the height of my rectangle. So I'm multiplying the base, 12.7 minus 2.3, which is 10.4, that's my base, multiplying that to my function, 1 over 20, to find the probability that my variable value is between 2.3 and 12.7. Big idea here for the big idea is that for a continuous probability function, probability calculations really are area calculations. And for a uniform distribution, like this example, we're simply calculating the area of a rectangle. We are going to learn about other continuous probability functions where the curve is a little more curvy. Stay tuned, that's coming next.